Hello, everybody. Thanks for joining us. Welcome to Discharge, Mapping, Modeling, and Beyond, the Hunt for Submerged Springs. And good morning, good afternoon, good evening, depending on where you are in the world. I'm Janice Lansfeld. I'm an application specialist here on the U.S. West Coast for SonTek and Xylem Analytics. As related to the topic today, I used to work for NOAA doing hydrographic surveying. I'm here with Isaac Jones. He's a technical support application engineer with SonTek, and he also does some work with R&D. Isaac was sort of the inception for this webinar because he was working with a group down in Florida that had this really interesting story to share. So we're going to be talking about that today.
All right, to start off, I'd like to thank Mitch Wainwright and St. John's River Water Management District. We did a training with them a little while back, right after they purchased HydroSurveyor product, and he provided some of these slides and let us share the work him and his team are doing. It's a really great team, and they're a lot of fun to work with.
So. Again, welcome to our application highlight. What we wanted to do with this webinar is highlight this customer story about the work that they're doing and how they're making the most out of their SonTek instrumentation. And in the process, we hope to give you some new ideas on how to tackle perhaps your own projects and how you might be able to get more out of your instrumentation. And at the end, we'll offer some opportunity for question and answers that you might have about how to do this particular kind of survey work. Some of you might have heard about our HydroSurveyor product and even seen an earlier webinar about it. We've also done webinars about the RiverSurveyor, which is related. And we hope to offer more value to those product-focused webinars through this opportunity to talk in practical examples. So while we go along, please don't hesitate to submit your questions, and we will make time for some Q&A at the end. Any questions that we don't get to in the we will send a document out to everybody and fully answer all of the questions. So please ask.
Okay, so who is the St. John's River Water Management District? They're a water management district that is located, they cover the area northeastern Florida. And here's a shot of their website with a guy using an M9 on a trimaran, which is the boat that's floating the instrument. Their mission is to manage and protect water resources of the region by balancing and improving water quality, flood control, and natural systems and water supply. So just an overall view of where they're at. So here's the United States, and they're located here in northeastern Florida. And this is actually a blow-up of Silver Springs, an area which they'll be working, which we'll be talking about today. And it's near Ocala, Florida. And so here's the team. This is from our training a little while back, and this was the setup that we used for this work that we will be talking about a little bit today.
Did you guys have to deal with any alligators down there?
Nope, only saw the warning signs.
Okay.
Unfortunately.
All right, you made it back alive.
Yeah.
So this is what the team has been using for several years now to do what their sort of normal baseline work is for discharge measurement. Initially, they have M9. The M9 is the image up here in the left for those of us who are not familiar. It's an acoustic Doppler current profiler, and up till now we've used it just for river discharge measurement. The software it's used with is called RiverSurveyor Live, and here's a cutout of what the discharge measurement will look like as you're transecting a river or a stream and your velocity data is showing up. And then the picture up here in the upper right is an example of the St. John's River Water Management District and the kind of boat that they might use to make their measurement. That yellow pontoon up there in the front is a trimaran that the instrument is floating in, pointing down, collecting the data while they paddle the boat from side to side. So that's just one example of how just normal way they're using the M9 for discharge measurement at one of their sites. So just to touch base and get everyone caught up with what exactly the M9 is doing when they're using it for river discharge. It has 9 acoustic beams on it, and these are the beams that are measuring the Doppler shift of the water while it's moving. There's one set of high-frequency beams for shallow water. There's a set of lower-frequency beams for deeper water, and then a down-looking vertical beam for essentially echo sounding and depth measurement. There's also a lot of other components that we'll hit on a little bit more, such as GPS and compass for heading. But sort of the take-home message of all these components and transducers is that the M9 sort of seamlessly moves from very shallow to deeper conditions, very slow-moving water, no minimum measurable velocity, even reversing velocity, so very low velocities to high velocities, and coordinates all of this internally. And the sort of one term that SonTek uses for this is a patented term called smart pulse. So the M9 uses smart pulse to do all of this switching. So some of us might be familiar with the M9, but what I want us to do here is make a mental note of just how many instruments we're actually talking about in this one instrument. It's a lot of transducers, it's GPS, it's compass, it's battery, it's the wiring and the push button integration. And so there's a lot of capability and flexibility that we have with all of these technologies. And up till now, just like Mitch and his team, we've been using it in the service of river discharge measurement. But since the purchase of their M9, Mitch and his team, their work has evolved beyond discharge to include some new requirements and goals that Isaac's going to talk to next. So one example of how their work is evolving is on the Silver Springs River.
So this is an overview, or this is a satellite photo of the Silver Springs River and the springs along it. And notice this is, the main spring is called Mammoth Springs, is up here at the head of the river. And I'm going to talk about a little bit more about that now. So the Mammoth Springs, the main spring, is provides 45% of the Silver Springs flow, and the discharge has been monitored by the USGS since 1906, and the discharge has ranged greatly from 1,290 CFS in 1960 to 250 in 2001, and these are just max and mins. It's not an overall trend. And the St. Johns River Water Management District recently started the process of setting minimum flows and levels for Silver Springs. So that's why one of the reasons that we're talking about this today. And so here's an illustration showing the standard spring flow conditions at Silver Springs, where you have a spring pool that's higher than the river that it's flowing into, and then the head of the spring is actually higher than the spring pool. So this is standard spring flow conditions. The spring is flowing into the pool, and then the pool is flowing into the river. However, currently they believe because of increased nitrates from runoff are causing increased vegetation in the river adjacent to the springs is causing this backwater flow condition. So increase in head, which in turn puts back pressure on the spring, and then the spring doesn't flow. Not as much water flows into the spring pool and then into the river eventually. So the board at St. Johns River Water Management District has started this spring protection initiative, and now they need more data. They need more data because they're in the process of setting minimum flows and levels, and they need more baseline data. And in addition to that, they need data to start a long-term modeling project. And for this modeling project, they're going to need bathymetry of the river and surrounding the springs, and then also velocity data, more than just discharge near the springs. And they already have the hardware to do this, or already had the hardware to do this. They had an M9, but now they've recently purchased HydroSurveyor, and with the M9, using the same instrument, now they're able to measure bathymetry and velocity data. And they're also using a CastAway.CTD.
So with that, we're going to stop and take a second and mention what is a HydroSurveyor. It's a product SonTek has had out, I don't know, about a year, I guess. But there seems to be some confusion about what the difference is, so we're going to go over that. So remember when I mentioned about the capabilities of the M9, and for RiverSurveyor, we've initially employed all of those tools in the service of river discharge. Well, there's a lot more we can do with that set of tools given a different set of programming, a different firmware, and a different software, and that's what we're calling the HydroSurveyor. So it's a velocity mapping, navigation, as the slide says, depth sounding system for performing hydrographic surveys from moving vessels. And fundamentally, again, the hardware is the same. So to, for example, upgrade a RiverSurveyor to a HydroSurveyor, it's a simple firmware upgrade to software, and it's a different piece of software. But we're still talking about the same tool. Actually, can you go back, Isaac, for just one second? So there's a lot going on in this slide, and you'll hit on it a bit later. But conceptually, all of these arrows point to the vectors, the flow vectors that are being measured by the M9, and all of these things are also happening when RiverSurveyor is at work. We're measuring a profile of the velocity at different levels in the water column. And we're also measuring the depth. We're doing what's called bottom tracking with each of these side-looking beams, but then we're measuring depth with the bottom-looking beam. One fundamental difference is that HydroSurveyor gets depth information from the side-looking beams as well as the down-looking beam. In RiverSurveyor, you only get it from the down-looking beam. But basically, we're getting velocity profile, we're getting bottom tracking for navigation, we're getting depth. But the way the survey is being conducted is very different from a back and forth discharge measurement survey. So that's kind of what I wanted to point out in that graphic. And what's the end result of when you're going to be using the HydroSurveyor? One of the main ones is bathymetric surveys. So in other words, gathering data about the bottom. So you might need to do this for morphology studies and how it's changing, for fish habitat, for example, for volume calculations, how much water is in a given water body or capable of holding, monitoring depth for any other kind of survey work or construction work. And the end product would be to turn this data into a map and help you do perhaps modeling work, which is what the St. John's River team is ultimately trying to do. Another distinction about what kind of goal you might have with the HydroSurveyor is a velocity survey. And what I wanted to point out here is that velocity surveys are different from discharge surveys, even though they're related. So again, the RiverSurveyor firmware and software definitely measures velocity in a profiler, and that's what any acoustic Doppler profiler does, fundamentally. But the RiverSurveyor focuses you on the end goal of discharge. And in some cases, you need velocity data in its own right, described spatially, that's capable of being mapped, that's studied and used for modeling purposes. So besides bathymetry, this is another functionality that's offered by the HydroSurveyor, and it's both of these functionalities that the team found useful in their project.
Okay, so we've thrown a lot out there at you, so I'm going to take a minute to recap and kind of show the pieces of the HydroSurveyor. So first off, we have the M9, which, as Janice says, it's an acoustic Doppler profiler. Many of you know that these instruments by ADPs or ADCPs, and basically it measures the velocity, bathymetry, and navigation, and it's also doing navigation with bottom track. And then also it's giving position of the vessel and position of these measurements, both from the M9 and from GPS, has integrated GPS. And then also, and then here's the software being run by somebody who's navigating the survey. And so that's another piece. And then here's the CastAway.CTD. And the CastAway is used for sound speed correction for the depths and for the acoustics that are used in the M9. And here on the right-hand side gives you a better sense of scale for the CastAway. It's actually a little bigger than somebody's palm, bigger than somebody's hand, not actually the size of this guy's leg as it looks.
I know. I think that every time I see that picture. And Isaac, at the bottom there, it says velocity plus bathymetry plus navigation. I think in my last couple slides I talked about velocity and bathymetry. Can you talk about maybe what that word navigation means?
Yeah, so so navigation means that the system can use GPS to navigate, and then also can use bottom track to navigate when GPS is lost.
So the instrument is actually acoustically tracking the bottom as well to give us a boat speed and direction. So that's why we have this. That's why we have this arrow pointing to the fact that you can do navigation from the Doppler itself.
Thank you, Janice. So here's the CastAway software, which is fully integrated into the HydroSurveyor software as well. So this is showing different cast locations. The CastAway has GPS, so it takes the location of your cast, and that's stored in with the data. And these blue dots are showing different cast locations, and separate ones can be selected and then shown here on the right. Okay, and then so the CastAway data is fully integrated into the RiverSurveyor Live software. So here, this is showing the RiverSurveyor Live software, and this is a measurement that has been done, and then CTD data from the CastAway that has been imported here as this yellow dot. And if you hover over or click on this dot, you can get the information that was recorded by the CastAway. And the CastAway data is also fully integrated into the HydroSurveyor software. So here's a screen capture of the HydroSurveyor software, and then you can see these small CastAway icons. That's the locations where casts were taken during this this measurement. And this is actually data from training with the St. Johns River Water Management Districts at Salt Springs, an area nearby Silver Springs. And these are the actual casts. If you click on one of the cast locations, you can look at the sound speed profile. And here you can see that from the top to the bottom, or you might not be able to see too well, but from the top to the bottom, the sound speed changes by 2 feet per second. So this may be important when they're looking at large temperature gradients with these colder springs and warmer water in the rivers. Okay, so here I'm going to start from the beginning and kind of show you a simplified version, but of how to set up the HydroSurveyor software, like I did with Mitch and his team. So here's the start. You get a blank screen, and you get to configure it how you'd like. So the first thing we did is add a map. So here's Florida, and then we're going to zoom in here to the area where Salt Springs is. So here's the local survey area, and then here's you can add as many profiles or time series as you like. But here I'm showing the SNR profile on the side, which is basically data quality for the acoustic Doppler profiler, and then down here a color map of velocity during the survey. And then next, we've planned out the survey. So there's a tool to draw line plans and plan out your survey, and that's what's shown here. These are the survey grids. So each one of these lines is a planned out survey path. And then here is after the survey. This is the boat track that was taken, and thanks to a great boat driver, this was easily done in less than half a day. Where with some trainings, it's learning how to drive the boat and survey at the same time.
Yeah, especially because the software will tell you how far you are off the line, and the HydroSurveyor software even keeps track of what percentage of the time you're actually you're actually on the line, and it will tell you if you need to redo it.
Yes, and thank you for mentioning that, Janice. It reminds me, this the top bar here is a navigation tool. So once you're on your line, it will show you how close to the middle of the line you are, and then so you can use this to steer, as well as you're going to see the boat moving on the screen in real time, and you can zoom in, zoom out to get it just how you'd like for the driver.
I don't know. Oh, I think if you were going to mention it about the CastAway data showing up in real time.
Oh yes, so during your survey, you can take your cast, and then if you start up the CastAway software, the CastAway will automatically download the data via Bluetooth. And if you have both the CastAway software and the HydroSurveyor running at the same time, then you can import the data real time as you go.
So in other words, that sound velocity data isn't just a post-processing process. You'll see those little CastAway icons. They're going to appear on the screen in real time, so you'll know while you're conducting the survey in real time where your casts were, and perhaps if it was enough, or if you got enough spatial variability in your cast. So this is real time showing up on the screen, not just after the fact.
And also something that's worth mentioning about the CastAway data is it's interpolated in both. The corrections are interpolated in both space and time. So the HydroSurveyor software uses an algorithm that looks for the closest cast both in time and space to the data points that it's going to correct for. So here is the software after having surveyed the area. This is the interpolated bathymetry. So you can see there's a hole over here. Yellow is shallow, and blue is deeper. And this is a hole right in this area, and it's shallow. That gives you an idea of and this is something you can do right after having collected the data.
Well, you can interpolate. You can produce an interpolated bathymetry graphic like that on the fly as well. That is one of the features. Yes, you turn it on in the layer. So if you want to see it, it's available. Sometimes it can get in the way when you're trying just to run a straight line. Maybe you don't want the pretty picture showing up. But it's doable if you want to see it. Maybe stop and assess where you are and what your coverage is. So yeah, in summary, what we'd just like to do is cover what all is being done here. So the Water Management District team is using now a combination RiverSurveyor, HydroSurveyor to measure river discharge and actually the spring, just try to get a handle on what the discharge of the springs are in the context of the larger river. And they can do that with the detailed profile information from the M9. They can map the bathymetry of the area that they're surveying. They can do that with the HydroSurveyor. They're mapping velocity fields. They're mapping the spring locations with the velocity field information combined with the GPS latitude and longitude information. And they're correcting for all of this data using the CastAway.CTD, which integrates with the software. And one thing we didn't really talk about a whole lot because it relates, more to CTD data, but because they're choosing to use the CTD for their sound velocity corrections, they're getting additional scientific data about the water masses in the river. So they're getting, in other words, conductivity data and temperature data every time they make a cast. And they can use that conductivity and temperature data to differentiate what might be spring water from the rest of the river water. You don't have to use a CTD when you're doing hydrographic surveying or for sound speed corrections. There are other instruments out there that just will give you sound speed and a sound speed profile. But in a different project like this, where you're maybe perhaps doing multiple things, it's an example of where a CTD comes in handy to give you a little bit extra scientific data.
All right, so again, to kind of wrap things up, the St. John's River Water Management District was able to expand their capabilities using the same instrument. So without new hardware, they're using the same hardware in M9, and they're able to use their existing survey vessel, and they're also able to use the same guys, same team can do this work with minimal training, and no troubleshooting different components. You're not trying to integrate one manufacturer's GPS with another manufacturer's echo sounder and other different parts. And then also, so to sum it up, it's simple: push button integration equals time saved using the M9 and the HydroSurveyor. So again, just to kind of sum it up for what the different softwares are and clarify a little bit, the M9 is one tool that can be used for multiple jobs. So the Water Management District is able to do moving boat discharge measurements using RiverSurveyor Live and the M9. They're able to do stationary discharge measurements using RiverSurveyor Stationary Live, so different software, but still the M9. And then they're able to measure bathymetry using HydroSurveyor software, and velocity, they're able to map velocity also using HydroSurveyor software. And all of these are integrated with the CastAway.CTD to correct data for sound speed, and then you're also getting conductivity, temperature, and depth data. So kind of just to bring it full circle, here's the Silver Springs River, and where the Water Management District will be measuring discharge and then also mapping the bathymetry and velocity around these springs and along the whole river, and to try and help get a handle on this problem with backwater flow conditions restricting spring flow. And then so here's a kind of overall images that kind of sum it up. So here's them making a discharge measurement. Here's a discharge measurement from RiverSurveyor Live. And then here's their setup for using HydroSurveyor. And then this is the bathymetry that resulted from the training. And this is like what they will be surveying, or what they will be doing at Silver Springs as well.
Yeah, and ultimately what they're trying to do is build a model of the river system to get that baseline understanding and inform their water management practices with this data and with this evolving model to continue their mission of ensuring that water quantities and qualities for the ecosystems and the people of Florida are being managed wisely. So hopefully seeing this example has offered you thinking about what possibilities might be within reach, whether you own an M9 already or you're just looking to expand your survey work. So maybe others of you out there have your own ideas in mind of what new surveys and projects you might be able to explore with the capabilities that we've expanded in these two different software and firmware packages. So with that, we've kind of made it short and sweet, and we have a decent amount of time to answer everybody's questions because they have been coming in. Let's do that. First question, can the M9 be deployed at depth in a spring? Short answer is no. The M9 currently is a down-looking instrument, so it has to be used from the surface from a floating platform such as a boat or a hydroboard or a trimaran. And additionally, it does not have an autonomous mode, so it operates through software. You can't just deploy it on a bottom mount and let it run autonomously. So it has to be used from the surface, and it is controlled by the software. And it's looking for GPS information that requires a radio connection. So unfortunately, no.
Okay, next question. Does the RiverSurveyor do anything that HydroSurveyor does not? The Discharge,
number
yeah.
one.
Number one, HydroSurveyor doesn't compute discharge, but otherwise it measures the velocity and depth. There's more capability, other than computing discharge, there's more capability in the HydroSurveyor software than there is in the RiverSurveyor software for mapping. Position can be, the position in HydroSurveyor can go between GPS and bottom track. It's one good thing to note.
Yeah, we didn't want to get too much into the weeds about the HydroSurveyor. There are a lot of other capabilities that come in when you're doing hydrographic surveying with the HydroSurveyor. So, for example, if you lose your position because you might be surveying under a bridge or in near large vessels, or there's multipath obstructing or influencing your GPS, the HydroSurveyor will switch from GPS to calculating a latitude and longitude from bottom tracking, and there's even what we call this snap function that will calculate any bottom track drift. So we can answer more specific questions if you're interested in that particular feature, for example, but that's one very specific feature that HydroSurveyor does that RiverSurveyor does not, because it's being used in the service of hydrographic surveying versus river surveying, river discharge surveying. River discharge surveying, you're probably not going to be tooling around risking losing GPS under a bridge because you've already set out to do your survey, transected a certain location, and you're just going back and forth doing your transects. So it can also be said that the RiverSurveyor does do some things better than HydroSurveyor. For example, show you much more clearly what your velocity profile looks like in detail from left to right bank as you go along. Because when you're doing river discharge, you want to monitor what's going on as you're making that transect back and forth. So visualization for the RiverSurveyor will be better for that kind of work. You really don't get that kind of visualization in the HydroSurveyor. You get different visualization for your line planning and for your boat driving execution and things like CastAway integration. those are good questions of kind of the whole purpose of this webinar.
Yeah.
Let's see. A lot of those questions were very similar to that one. Okay, moving on to the next one. Can the S5 be converted to HydroSurveyor? Is it compatible? First of all, S5 is the cousin of the M9. The S5 is also an acoustic Doppler profiler river surveyor, but it's for more shallow water. That's what the S stands for. And we want to know if it can be used for hydrographic.
Yeah, and unfortunately the answer is no. For now, the HydroSurveyor can only be used with the M9. And part of this is the depth restrictions on the S5.
Next question, can it be used in a cave or will the beams bounce off the walls? We might have answered this question earlier about using it under autonomously in a spring. If the cave is big enough and you're talking about using it from a floating platform and surveying in the cave from the surface, it could definitely be done. It sounds like, though, you might be concerned about I don't know, the narrowness of the cave, and yeah, it is a possibility. It sounds like a question we might need more information on, but yeah, what you can do when you're using the HydroSurveyor or RiverSurveyor in a narrow area and you're suspecting it's beams bouncing off the wall, you can bring up the profile graphic of each beam. Each of the 4 beams that are operating at any one time, you can see the beam pattern and watch for a spike too high up in the water column. So there's ways to tell whether you're hitting the side of a wall, for example. So can the M9 be upgraded without changing firmware?
So that's a tricky one. If it already has, so the newest firmware includes both HydroSurveyor and RiverSurveyor capability, and the license is what enables it to run. So you can get it licensed for RiverSurveyor or HydroSurveyor or both, or and also stationary RiverSurveyor stationary live. So the firmware, if the firmware is the most recent firmware, then you can enable HydroSurveyor without upgrading the firmware. All you need to do is purchase the license and then enter in your license in the software, and then you'll be enabled to run HydroSurveyor. And that gets to a good point also. The HydroSurveyor software is available to download on as many computers as you need. So you can have multiple people using the HydroSurveyor with same M9, but they can have the HydroSurveyor software installed on their own computer.
And I'm going to throw some related questions at you, Isaac, because these are different but related.
Okay, so the next question is, can you run both the RiverSurveyor and HydroSurveyor at the same time? The simple answer is no, not at the same time. You can have one M9 that's enabled for both, and you can use both, but you have to be using one or the other. So, for example, you could go out and make a RiverSurveyor discharge measurement, and then once you've completed that, you can switch over to the HydroSurveyor software and run that and do a survey in the same location.
Right. The point is that if you have a RiverSurveyor and you want to upgrade it to a HydroSurveyor, you get the firmware upgrade, and that's all you have to do with the firmware. So there was another question about how easy it is to switch back and forth between the two. It's as easy as closing down one software and opening up the other. So you don't have to go back in and reload firmware or change some sort of internal switch. It's just changing the software that you're using to operate it. So speaking of software,
so the next question is, what is the significance of the black area between the bottom data and the bottom of the water?
Trying to get back to where we had a nice picture. I think this is what we're talking about.
Yeah, so if this is what, so this black area here underneath the velocity, that's the velocity profile. So that's actually an area that the M9 can't accurately measure the water velocity, and that has to do specifically with the acoustics. It has to cut back a certain distance from the bottom. So with the vertical beam, you can very accurately tell where the bottom is and get a detailed profile of the bottom, but just the nature of the acoustics, you can't actually measure the velocities accurately all the way down to the bottom. So that's what that black area is. It's showing an area that's not measured.
There actually is data down here. If you wanted to see it, you could. We filter this because it's standard practice based on years of experience and analysis at a known value, which is usually 10%. The data exists, but like Isaac said, just to keep your data clean, to rule out bottom reflections and side lobe interference. Let's see. Can you see vegetation on the ADP? I assume that means regarding echo sound, whether or not when you're making a survey, whether it's RiverSurveyor and you're seeing what the acoustic return looks like off the bottom, or I guess in HydroSurveyor, this would be more akin to your echo sounder trace. Or is this?
This is velocity.
This is velocity data.
Yeah.
Do we have a picture that will show? This is our echo sounder trace.
Yeah.
Or
so
not?
That's the bottom is velocity data, and
okay.
That's the bottom.
I guess we did not do a screen grab to illustrate exactly this. Okay. Okay, sorry. Basically, what I was trying to do is show that you can plot in the HydroSurveyor software. You can arrange this screen to be bigger if you like, or undock it and float it anywhere, or maybe even to a second screen. But this area down here would be analogous to an echo sounder trace. If you're familiar with surveying with single beam echo sounders, we would give you a plot of the signal return intensity and then a line showing you where we digitized the hard return from the bottom. But aside from the hard return from the bottom, often you can see other returns that would indicate vegetation, sort of lighter, maybe perhaps noisier looking return off the bottom that would help you quantify whether or not vegetation is down there.
But it does bring up a good point that if you are surveying with the HydroSurveyor, you need to be aware if there is vegetation present or not, and kind of quality check your data and make sure, see if you actually are tracking the bottom still, or if you might be tracking the top of the vegetation.
What correctors is the GPS using, and what is the accuracy? So the answer depends on which GPS you're choosing to use. You can use SonTek's, like we mentioned, push-button integrated GPS system, or you can use your own GPS system. But if you're using SonTek's, that's what we can speak to. There's two different options that we offer. One is just a basic sub-meter differential GPS that will take correctors from SBAS satellites, so geostationary satellites that provide sub-meter quality differential GPS correction, and generally that's 1 meter or less. There's also an RTK option that SonTek offers. In that case, we offer you an RTK base station that you would set up on shore, and the accuracy of that is on the order of 2 to 3 centimeters. And those correctors are sent via a radio link between the boat and the base station. And yeah, the GPS data that same setup can be used whether you're using RiverSurveyor or HydroSurveyor. You'll get the same. You can get either kind of GPS. Did I cover that one?
Yeah, you covered that well. Okay, so the next question, does the software correct for tidal changes if used in a coastal environment? an example is an estuary. Well, you can get the altitude data from the GPS, and so you have an option of doing a fixed water level elevation, or you can let that float and be referenced from the GPS. So in that case, yes, if it's a slowly changing water level, then you're going to get the altitude of the bottom, or the elevation of the bottom will be corrected for tidal changes.
Kind of we would need more specifics about the exact goal you're trying to accomplish with tidal changes. If you're familiar with other software such as HYPACK or Keras, for example, we do not have a button that will let you upload a tide file. So if you're working in a coastal environment that's influenced by the tides, and the tides are going up and down while you're surveying, the short answer is the RiverSurveyor will not upload a tide corrector file. And let me pull this question. It's a related question. Can you talk about the RTK setup for navigation? I'm interested in the vertical datum referenced for the bathy datum collected. I think Isaac hit on that. You can input a known RTK base station location from a survey point if you have one, and use the ellipsoid reference. Kind of related to my previous answer to loading up a tide file, we don't do tidal datum. So if you're looking for like a mean low or low water or that kind of thing, those bathymetric datums are not supported. What you could do, we haven't talked about it yet, it's a common question about using the M9 with HYPACK. What you could do is take your XYZ bathymetry data, export it from HydroSurveyor, and you can import, it's just text data, import that into HYPACK, a software program that could do tidal correction. So you could import that to a HYPACK project and do some more advanced post-processing if you're a more advanced hydrographic surveyor. Okay, let's see. Well, this one came in that's somewhat related, so let's do that. What is the range of the base station?
So that depends. It depends on line of sight, and but it gets up to about 2 kilometers from the base station to the PCM. And that's going to depend on how close. The most significant effects on that are how close it is to the water. So if you get the RTK base station up off of the water in a high location, get the antenna high, then you're going to get better range. And then also, if you're not within line of sight, it's going to somewhat restrict your range.
Now we have some questions about the CastAway. Concerning the CTD with Bluetooth, does the CTD communicate directly with your laptop or the M9? If a laptop, is there a chance the Bluetooth from the M9 will conflict with Bluetooth from the CTD?
So actually, so the CTD does, the CastAway does connect directly to your laptop, and the CastAway comes with a Bluetooth dongle, so a USB antenna that you can plug in and will automatically connect and download. And the two don't conflict that I've seen. I guess it's possible, but in the field with the Pirani Bluetooth and the CastAway with its own separate antenna, I've been able to do both. And then actually the newer PCMs use a 2.4 gigahertz antenna, so same frequency as Bluetooth, but it's a different protocol. So those do not conflict.
Right, and for example, they're coming in on different communication ports, COM ports. as well. So we haven't seen it conflict. And does the CastAway provide georeference profiles, or do I have to input GPS data with another device?
CastAway does has a GPS in it, and it does reference position, the profiles to georeference position.
Right. Sounds like somebody has experienced what I've experienced multiple times in surveying, where you're using a CTD. The CastAway, to our knowledge, is the only CTD that has a built-in GPS. So you just throw it over the side and you know where you were when that cast was taken. So any other CTD you might have used, you might have done what I've done, which is throw it over the side, lower it down, haul it back up, bring it in, disconnect the cords, upload your data. You're driving on to the next site. You get back in the office. Hey, did you mark the position of that CastAway cast? No, I thought you hit the GPS. No, I thought you hit the GPS. Ah!
and so this is this shows this is the CastAway software, and these cast locations are automatically mapped from the GPS data from the CastAway. One thing to make sure is that you have a GPS lock before you make the cast, because it is possible to perform a cast without GPS, and then you need to enter in that information yourself. But you can also just pay attention, and as long as there's good GPS coverage, you know when it has GPS lock, and then make the cast. So the next question, how often do you deploy the CastAway? So that's going to depend on your survey area. So for these small survey areas, we did one at the beginning, one during the middle, or one at the middle, and then one at the end, and try to get spatial spread, so we weren't doing all of the casts in the same location, and that's in consideration of that the CastAway data is interpolated in space and time. So you want to get a good coverage of your area spatially, and then also temporally. You want to make sure to have them spaced out. So if you have a very large survey area, and also if you're expecting gradients, if you expect there to be significant changes in the salinity or temperature, then you're going to want to do more CastAway casts.
Okay. Can the HydroSurveyor account for wavy lake surfaces? I'm assuming we're talking about if there's wind out on the lake when you're surveying and the boat is doing a lot of pitching and rolling. Can the HydroSurveyor account for that? There is heading, pitch, and roll sensing within the M9 instrument. So you will, when you set up the instrument and mount it on your boat, you'll program where on the boat the instrument is, and that accelerometer data, the heading, pitch, and roll, is recorded, and that data are used to compensate for your depth and velocity. So in that way, it does account for waves on a lake surface. Okay, one more question on lakes. Does the HydroSurveyor have a feature to calculate lake volume? What output files are available with GIS applications? So no, the HydroSurveyor software itself does not calculate lake volume. The HydroSurveyor will allow you to do line planning and conduct a hydrographic survey, collect the bathymetry data. It will actually grid that data for you, which is a lot of processing. What you would do in the next step, if you wanted to calculate lake volume, is take that grid and export it to another GIS application, whether it's an Esri or a Keras HYPACK, and then proceed with your post-processing from there. And I think people are still writing in with lots of questions. So what we're going to do is wrap up, and we will compile the rest of these questions in an FAQ document after the webinar is over. So thank you for attending. You will be getting that FAQ document. You will be getting a link to this PowerPoint presentation too.
Yeah, thank you everyone.